Alright, this problem is really similar to problem 21 on your retake assignment, so if you go there you can practice one after I show you how to do this one. Now we're going to take this left hand of our equation and we're going to rewrite it as a single logarithm. It can be condensed to log of x times x minus 3. Since everything has the same base, we can do that. And then on this right hand side we have log 54. Now since we have log of something on the left hand side equals log of something on the right hand side, everything has the same base, then we can forget about the logs altogether and concentrate on what we're taking logarithm of. Since if you take the logarithm of some number and the logarithm of another and they're equal, then those numbers that you took logarithm of have to be the same. So what we're going to do is we're going to distribute the x here on this side, and we're going to have a quadratic equation to solve. So we'll have x squared, sorry, that should be minus 3x equals 54. And from here you can choose whatever way you like to solve your quadratic equations. You can complete the square, you can factor it, you can use the quadratic formula, whichever way you find easiest. For me, if it factors, and this one I believe does, that's the easiest way to do it. So I'm going to subtract 54 from both sides and then see about factoring it. And then it'll give me two solutions. One thing that we have to remember, since the original equation says log of x, we have to make sure that whatever we find x to be, it's not 0 and it's not a negative number, because we can't do logarithms for 0 or negative numbers. So if this one factors, we need x's to get x squared, and the signs are going to be different because it's negative 54 at the end. So now we're looking for two factors of 54 that are different, because you subtract when the signs are different. They're different by 3. So 54 is 9 times 6, and those differ by 3. And we want it to be negative 3, so we'll put the larger number behind the negative. Oh, I wrote down the wrong thing. 6. So now we have, if we want to check it, we have x squared if we do our first terms, plus 6x if we multiply the middle terms, and then we have minus 9x if we do our outer terms, and plus 6x minus 9x does give us a minus 3x, so that works. And then at the end we would have the positive 6 times negative 9, which does give us negative 54. So that is how that factors. So now we're going to set each factor equal to 0 and solve. And on this one we get negative 6 for an answer, but that doesn't work with logarithms. We can't do log of negative 6. That won't work. So that's not really an answer. On this side we get plus 9, positive 9 for an answer, and that does work. We can take the logarithm of 9. So that's how this problem works. Now this problem is a system of equations, and it says solve by the substitution method, and that's probably the easiest way to do this one anyway. So the easiest thing to try to solve is the top equation. If we solve it for either x or y, it's going to look very similar either way. Then we can substitute that value into the bottom equation. So the way we can solve this, and I'm just going to go ahead and solve for x, it really doesn't matter, but the way to do that is to divide both sides by y. That's going to give us x equals to a divided by y. So I'm going to plug that into the other equation where the x squared goes. So it's going to look like 8 over y squared plus y squared equals 20. So I'm going to go ahead and square, and I'm going to have, when you square fraction, you just make sure you square the numerator and the denominator, because it's basically it's just 8 over y times 8 over y. So you get 64 over y squared plus y squared equals 20. Now this one's a little bit messy because we have this y squared in the bottom of a fraction, and that's not really going to work. So what we're going to have to do is get it out of the denominator, and the only way that we can do that is to multiply through the entire equation by a y squared. That way we can cancel that out. So when we do that, we get 64, because the y squares cancel in the first term, plus, and y squared times y squared is y to the 4th equals, and then we'll have a 20 y squared. So I'm going to rearrange this and see if I can factor it. I'd like to have my y to the 4th first, and then I'd like everything on the same side of the equation so I can factor. So I'll go ahead and subtract 20y squared. And what that gives me is y to the 4th minus 20y squared plus 64 equals 0. Now, to factor this, to get a y to the 4th power, we need y squared times y squared. And that's going to work out well because our middle term comes from our inners when you multiply them and your outers when you multiply those. And I can see that we're going to have something times a y squared for both of these, so we should have a y squared in the middle. And since it's a positive 64 that we're looking at, the signs are going to be the same, and then so we look to the middle term to see what the signs are. They're both negative. Negative times negative will give us a positive 64, and negative plus a negative will give us a negative in the middle. So we are looking for factors of 64 that add up to, because they have the same sign, 20. So now that 8 times 8 gives us 64, but that only adds up to 16, so that one's not going to work. So we have to think of some other factors of 64. And since I know that it's a multiple of 8, it's got to be a multiple of 4. So I'm going to think about, well, it's 4 times what? And this, in this case, is 4 times 16. And 4 plus 16 does give us 20, so those are the factors we're looking for. But you could list out your factors and see which ones would add up to 20. And since the signs are the same, it really doesn't matter which one you put where. So now we have two equations that we need to set up and solve. And since this one was a y to the 4th, we end up with 4 answers here. If we solve this one by adding 4 to both sides, we get y squared is equal to 4. Now when we take the square root of both sides to get an answer, what we get is y is equal to positive or negative 2. I almost wrote 4 again for some reason. And on this one, if we add 16 to both sides, we get y squared is equal to 16, and when we take the square root of both sides on that one, we get y is equal to a positive or a negative 4. So those are your 4 answers for y. So we have to figure out what our answers that go with those for x would be. So we'll plug them in. 2 x times 2 is equal to 8 is going to give us x equals 4 for an answer. So if y is equal to 2, then x is equal to 4. Then if we plug in negative 2 for y, so that should give us negative 2x is equal to 8, then we'll get x is equal to negative 4. So for y equals plus or minus 4, we can do the same thing. We're going to take 4 and plug it in, and the easiest one to do is the top equation, so that's the one I did. 4x is equal to 8 is going to give us x equal to 2. Negative 4x equal to 8 is going to give us x is equal to -2. So those are the solutions we have. We can check those real quick with the x squared plus y squared. If we use 2 for y and 4 for x, that's going to give us a 4 for the x squared plus 16 for the y squared, and 4 plus 16 is 20. So you can check those all just like that. Plug those values back into your equation to see what to make sure that they work.